Hi everyone, in this video I will discuss arithmetic sequence. Specifically, I will teach you the overview of sequences, writing the explicit formula of an arithmetic sequence, and finding the nth term of an arithmetic sequence. Let's define first what is a sequence. A sequence is basically a finite or infinite list of terms or numbers arranged in a definite order. That is, there is a rule by which each term after the first may be found. The terms or numbers in this ordered list are called the elements of the sequence. A sequence may be named or referred to by an uppercase letter such as A or S. The terms of a sequence are usually named something like A sub 1 or A sub n, with the subscripted letter I or N being the index or the counter. So the second term of a sequence might be named as A sub 2, and A sub 12 would designate the 12th term. There are two types of sequences, generally speaking. We have the finite sequence and the infinite sequence. The difference between the two is obvious. Finite sequence is a sequence with a definite number of terms. On the other hand, an infinite sequence is a sequence with an indefinite number of terms, meaning we cannot add all of those terms. It's infinite, it's indefinite. So by these examples, you will notice that the big difference between A and B, which are examples of infinite sequences, and then C and D. So with A and B, you see, for letter A, you see number 4. After that, comma, the 3 dots, that signifies that the sequence is infinite. Also with letter B. On the other hand, we have C and D. We can clearly see that we have 1, 3, 5, 7, or 4 terms in this sequence. Also with letter D, there are also 4 terms in the sequence. So they are called finite sequence. Now let's discuss what is an arithmetic sequence. It is a number of sequence or a number sequence where each new term after the first is obtained by adding a constant d called the common difference to the preceding term. So the question here is, what makes an arithmetic sequence arithmetic? Well, you need to have a common difference. Okay? Examples. For letter A, we have -8, -5, -3, and +1. As you can see, from -8 to -5, there is an increase of 3. From -5 to -2, there is an increase of 3. And from -2 to +1, there is an increase of 3. And maybe you're asking, how did you know that it's 3? So all you need to do is to subtract any two succeeding terms. It's like that term or the present term minus the preceding term. So it's, for letter A, we can have -5 minus -8, right? It's the same as -5 plus 8, and that will give us +3. Same way with -2 minus -5. It's also equal to +3, and 1 minus -2. Letter B, we have 3, -1, -5, and -9. This time, the sequence is decreasing. So we put -4, which is the common difference, -4, and also here we have -4. Again, how do you know -4, or how are we going to find out the common difference? So for letter B, it's the second term minus the first, and that will give us -4. Okay? That's the same with -5 minus -1. For letter C, we have 1/2, and then it becomes 1, and then it becomes 3/2, and then +2. And obviously here, the increase is 1/2, or 0.5. Okay? So as you notice, A and C are increasing. So if the sequence or the arithmetic sequence is increasing, the common difference is positive. If the arithmetic sequence is decreasing, then the common difference is negative. Now, let's check first our knowledge about the previous slide. Identify the sequences that are arithmetic in nature. If it's arithmetic, then what is the common difference? Letter A. Is that an arithmetic sequence? Let's check. So here, the difference between 5 and 7 is positive 2. The difference between 7 and 10 is positive 3. So we can stop there because we can see that the differences are not equal. Therefore, letter A is not an arithmetic sequence. What about letter B? We have 3 to 10, which is equal to 7, and then 10 to 17, which is equal to 7, 17 to 24, which is also equal to 7. So we can conclude that letter B is an arithmetic sequence. For letter C, we have 1 to 4, which is 3, 4 to 7, which is also 3, and then 7 to 10, which is also 3. So we can conclude, since all the differences are equal, that letter C is an example of arithmetic sequence. What about letter D? We have 9 to 20, which is 11, 20 to 29, which is 9. And we can stop there because obviously 11 is not equal to 9. So letter D is not an example of arithmetic sequence. How about letter E? So you have 18, 22, 24, and 30. 26 and 30. Guess what? That is right. This is an example of arithmetic sequence because the difference between any two succeeding terms are equal, the differences. Okay? So letter E is an arithmetic sequence. Now let's go to the writing the explicit formula of an arithmetic sequence. Write the explicit formula of this sequence, 2, 6, 10, and 14. So to do that, we have the formula for the indicated term of an arithmetic sequence. AN is the indicated term, A1 is the first term, D is the common difference, and N is the number of terms in the sequence. Okay. So for this one, all we need to do are these two variables. A1, which is the first term of the sequence, and that is positive 2, and D, which is the common difference. So to find the common difference, we just need to put 6 minus 2, which is equal to 4. So now that we have our D and our A1, we can simply replace these two variables by 2 and 4 respectively. So therefore, the general formula or the explicit formula of this sequence is, let's see, 2 plus 4 times n minus 1 equals 2 plus, that's right, we need to distribute this. So that's 4n minus 4. After that, we need to combine the constant numbers. Okay? But don't forget that term with n. So 4n minus 2, because 2 and negative 4 have different signs. So that means you need to subtract them. So this is the explicit formula of the sequence 2, 6, 10, and 14. Next, write the explicit formula of this sequence. Again, just like what we did in the previous example, all we need to do is to know first the first term, which is 18, the common difference, which is 11 minus 18, and that is equal to negative 7. So once we know all these two variables, the next step we need to do is just replace A1 by 18 and that D by negative 7. Next, let's distribute this negative 7 to n and negative 1. So this is negative 7 n plus 8. No, not plus 8. Plus 7. Plus 7. Okay, plus 7. So negative 7 times negative 1 is positive 7. Negative 7 times n is negative 7n. Next, let's combine these two constant numbers, negative 7n plus 25. And that is our general formula or the explicit formula of the given sequence. Next, let's go to this subtopic, which is finding the nth term in an arithmetic sequence. So, what is the 71st term in this sequence? Okay, so just to give you an illustration, so we have the first number of the sequence, which is positive 2. The second number is 7. The next number is 12. And then the fourth number is 17. I know that if I ask you what is the fifth term, you know the answer to that, and that is 22, right? So we just keep on adding a certain number, and that's right, it's 5. Now, the question is, what is the 71st term of the sequence? So, the shortcut is by using this formula. So, let's find out what is the 71st term. First, we need to know these three variables. A1, which is the first term of the sequence, and that is obviously positive 2. Our D, which is the common difference, that is second minus the first, which is equal to 5. Okay, so we have now D, and we have A sub 1, or the first term. Next is N, which is obviously here. That's 71. So now that we know all these three variables, we just need to plug them in the formula. This is equal to positive 2 plus 5 times 71 minus 1 equals 2 plus 5 times 70 equals 2 plus 5 times 70 is equal to 350, right? Equals 350 plus 2 is 352. This is our A sub 71. Let's go to the next example, and the last one, I think. What is A sub 41 in the sequence negative 2, negative 8, negative 14, and negative 20? So here, again, just like what we did earlier, first we need to know the first term, which is obviously negative 2. Next is D, which is the second, which is the common difference of the sequence. That's negative 8 minus negative 2. That's equal to negative 8 plus 2, which is equal to negative 6. That's our D. These are A sub 1. Next, our N is obviously here. Okay, that's 41. So if you see this kind of problem, what is A sub 41? It's simply asking you about the 41st term of the sequence. So now let's go answer the problem. We have negative 2 plus negative 6 times 41 minus 1. Negative 2 plus negative 6 times 40. Negative 2 plus negative 240. Now, since both are negative, we just need to add these two numbers, and the result is negative 242. This is our 41st term. Okay. That's it. Thank you for watching.